Hi guys, today we're going to be talking about trig again. We're going to specifically talk about exact trig values. So just a reminder that we know sine is going to be opposite over hypotenuse, cosine is going to be adjacent over hypotenuse, and then tangent is going to be opposite over adjacent. We know SOHCAHTOA to help us. So here, let's say our theta is right here. So then we need to make sure we identify what our theta is. So theta, sine of theta is b over c. So cosecant of theta is going to be the reciprocal. So, cosine of theta is going to be adjacent over hypotenuse. Secant is going to be the reciprocal. And tangent is going to be opposite over adjacent. And cotangent will be the reciprocal. So we know all that. That's review. We are going to apply some of this knowledge to special right triangles so we can get exact trig values without having to use our calculators. So let's talk about some special right triangles to help get us started. So here, I'm going to say these two side lengths are the same. So if they're the same, this is an isosceles triangle. Isosceles triangles have these two side lengths being the same. Now, depending on who you talk to, they will set up this special right triangle differently. And it's not that they're necessarily extremely different. It's more that they just decide to rearrange the values in slightly different ways. Personally, I like to have these two side lengths be 1 and then the hypotenuse be root 2. And the other triangle I will let you guys know. Same setup, 45, 45. These are the same. Some people like to have it set up as root 2, and 2. And I'll talk about why in just a moment. But let's talk about finding this first exact trig value, and then I'll show you kind of where things change. So here, for this exact trig value, sine of 45 is opposite. It doesn't matter which one you choose, by the way. Is opposite over hypotenuse. So 1 over root 2. But I can't just leave it as 1 over root 2 because 1 over root 2 has an irrational denominator. So we need to rationalize it. And if you remember back from the past, to rationalize it, we can multiply by a fancy form of 1. Root 2 over 2 is just 1 because it's the same thing over the same thing. And then in the denominator, we're just left with 2, and in the numerator, we're just left with the square root of 2. So now we have it rationalized, and this is our exact trig value. If I use the pink triangle, I would get to the root 2 over 2 right away and have to not even do this step because I just get opposite over hypotenuse is root 2 over 2. However, where I don't like that is when I'm dealing with cosecant. Cosecant is one of your reciprocal trig functions, so we can switch this and have it 2 over root 2, but I don't like that because then I have to re-rationalize the denominator, right? But if I go back to what I had in the beginning and I see that it's just 1 over root 2, then I know I can just have it as root 2. And I would get that if I rationalize the denominator, but it's easier to see. The other thing you can think about is if you were just thinking about cosecant, instead of doing opposite over hypotenuse, it just becomes a reciprocal, so it's just hypotenuse over opposite. So that's just another way to think about it. Cosine is going to end up being the same thing because if we're using this angle again, it's 1 over root 2 adjacent over hypotenuse, which is just, if you rationalize it, root 2 over 2. So its reciprocal will just be root 2. Tangent is where things start to change a little bit because it's opposite over adjacent, which is just 1 over 1, or 1. So its reciprocal is just 1. Now, before we continue on any further and talk about any other ideas, I want to go back to that idea of where I said that cosecant was hypotenuse over opposite. So we know SOHCAHTOA, we talked about it up there, but if we have cosecant, instead of having it be like SOHCAHTOA, I can think of these not inverse, these reciprocal trig functions in a similar way with a different acronym. You can have it as opposite, or excuse me, hypotenuse over opposite. Then secant is going to be, instead of adjacent over hypotenuse, hypotenuse over adjacent because it's the reciprocal. And then tangent is going to be adjacent over opposite. So some people like to think about it like this. It's like coshateo. Some people like to think about it like that. Whatever works for you. This could be helpful as you're working on doing your exact trig functions. And there's a certain point where you're going to have to be able to do them really quickly. So figuring it out, what works for you, is going to be what's easiest. Before we continue onward, it's worth noting that you are going to actually also have to know these special right triangles as if you were given it in radians. So these are all degrees, and I probably should have put the degree sign on them. I really actually should have, but you need to know these exact trig values. If it said sine of pi over 4, sine of pi over 4 is the same thing as sine of 45 degrees. These are the same measure, but this is in radians and this is in degrees. So you are going to have to recognize that. And as we continue on, we'll talk about these special angles and what they are in radians. But of course, you can always use the conversion that we learned before. If we're going from degrees to radians, if we have 45 degrees, to get that to radians, we multiply it by pi over 180. And how I remember it is, again, instead of putting the 180 over pi, is that these degrees have to cancel to get it to radians. But that will get us to the pi over 4 for sure. And we're going to have to think about that for these as well. And we'll talk about this as we get to this next special right triangle. So our next special right triangle is going to have a degree of 60 here and 30 degrees. And before I even continue onward like I did over here, I do want to talk about what 30 degrees and 60 degrees is in radians. 30 degrees is when you multiply by pi over 180 degrees is going to give you pi over 6 in radians. So all of these 30 degrees could be replaced with pi over 6 and would mean the same thing. Similarly, 60 degrees in radians, when you multiply by pi over 180 degrees, you get pi over 3, which you can see down here. And this is all the same thing as if they were actually 60 degrees. Let's finish filling out this special right triangle with our side lengths. Across from 60 degrees, you're going to have the square root of 3. Across from 30 degrees, you're going to have the value of 1. And then your hypotenuse is going to be 2. Whatever way works for you to help you remember. I like to think of it as like the root 3 is going to be next to the 30 degrees. But then if you write the triangle with radians, that doesn't exactly work. And we'll write the triangles with radians and again a little bit later. But you are going to just need to know this triangle. And you're going to need to know the other triangle as well. But let's do it. So sine of 30 degrees. So 30 degrees, opposite over hypotenuse is 1/2. So then cosecant of 30 degrees, instead of being opposite over hypotenuse, it'll be hypotenuse over opposite. So that's just 2 over 1 or 2. Cosine of 30 degrees is going to be adjacent over hypotenuse, so root 3 over 2, and that's the denominator is rationalized, so that's good. Here we're going to have to do the opposite, so it's going to be hypotenuse over the adjacent for 30 degrees for secant. So this will be 2 over root 3. So we are going to have to rationalize this by multiplying the numerator and the denominator by the square root of 3. So this ends up being 2 root 3 over 3. Then tangent of 30 is going to be opposite over adjacent, so 1 over root 3. And this one's going to be very similar to what happens with the 1 over root 2. So this will be, end up, once you rationalize it, root 3 over 3. And then your cotangent is going to be, instead of 1 over root 3 over 1, or just root 3. And now we can continue on to thinking about 60 degrees, which in radians is pi over 3. So we're going to do the same thing. Actually, you're going to do the same thing. I'm going to pause the video in just a second with 60 degrees. But recognize this is the same thing as if I wrote sine of 60 degrees. That's the same thing. This is the same thing as sine or cosine of 60 degrees. And even up here, this is the same thing as tangent of pi over 6. So pause the video here, try these ones with 60 degrees on your own. So these are the exact values that you should get for 60 degrees for all of your trig functions. I'm sure you guys have noticed some similarities and some patterns. You are using the same triangle. There's a lot of different reasons for a lot of these patterns, and you're going to get into that further in the future in pre-calc. So we're just going to leave it there, but I also want to explore a little bit more with these triangles, but going in a different direction. So the different direction I'm referring to is, instead of giving you the angle, I'm giving you the exact value, and you have to work backwards, of course, without using your calculator and using inverse trig. So I'm going to have you guys pause the video in just a second. I want you guys to draw the special right triangles on your own. I'm going to rip the Band-Aid off. You got to figure it out. Got to know your special right triangles. Write them up here and write them with the degrees and the radians for their angles. So pause the video here. Give it a go. So here are my special right triangles. Got to know them. Now let's use them. So here, sine is opposite over hypotenuse. So opposite over hypotenuse. Ooh, that's a little bit funky because it's 1 over root 2, but we should hopefully get familiar and recognize that's the same thing as 1 over root 2. And that brings us back to what angle? Well, if we're on this triangle to deal with the root 2, the only other angle besides 90 degrees is 45 degrees. So 45 degrees, which we know is the same thing as pi over 4 radians. Let's take a look at, let's try cosine of 1/2. So cosine of 1/2, I noticed that this 2 doesn't have a square root, so I'm going to automatically go to this triangle because this 2 has the square root sign. So 1 over 2, and it's cosine, so I want it to be, this is the adjacent, that's the hypotenuse. So that's going to be, it's adjacent to pi over 3, or 60 degrees, or pi over 3. I just gave you 2 examples. I'm going to have you guys try the rest on your own. Work with your triangles, try to work backwards, and pause the video here. So here are the values you should have gotten. If you have questions, please make sure you double check your work. And then if you're solving trouble, come in for student support or ask questions, send me a message. I didn't include any of the reciprocal functions in here, but that doesn't mean that we aren't going to be able to know them. I'm going to have you guys kind of figure those out on your assignment. But that's all I have for you guys today. Have a good one.